Hello there, welcome to this lesson under the course Fundamentals of Information Systems. I know I have previously said that the titling of the course Fundamentals of Information Systems is a bit off the mark. If it was me who was going to name this course, I would have called it Fundamentals of Networking. Because you realize that most of the stuff that you are covering in this course are mainly the basics of networking. So fundamentals of networking would have been more appropriate than the current title we are using. Hopefully in future it will be changed and aligned accordingly. So today we want to look at the last aspect of our course, that is our course outline, and the following are the main areas that we are going to be looking at that focus on administration of networks. So we'll first look at how you configure network devices or network services. I think one thing you have to appreciate as a network administrator is one of the key things that we are supposed or that you should be able to perform is to configure various networking components, be it hardware components, software components. So you should be able to appreciate and understand how various devices are configured for them to function on a network. Then we'll look at how you connect to networks, be it using wired connections or wireless connections, and how you configure device again to connect to networks. We'll look at administration of networks using various tools. Then we'll talk about the roles of a network administrator, so that at least as an administrator you are familiar or you appreciate what is it that you're expected to do as a network administrator. And lastly, we'll talk about user accounts. So you realize that for you to access certain network resources, or let me use the term resource because it's encompassing, it covers both the software, the software resources and the hardware resources. You need to have credentials, what we call usernames and passwords, that will allow you to access and use services on a network. So we'll look at that. But for you to be able to configure services or a device so that they are able to connect to a network, you first need to appreciate and understand the concept of IP addresses. Simply put, an IP address is a pointer to a resource on a network. It's a specific pointer or a unique pointer to a specific resource on a network, be it a software resource or a hardware resource. If we were to simplify it, we would say it's a house number or a location number to a resource on a network. So in terms of networking definitions, you can define it as a unique string of numbers separated by periods that identify each computer using what? The internet. Or it's a numeric identity to an interface, or it's an address for your computer so that the internet knows where to send your relevant files. In other terms, we can say the concept of IP addresses was inspired by the physical addresses that we use in our homes. where we know your house number is 7270, your location is probably Budiriro, your seat is probably Harare. All that makes up your address. So the periods that are in the IP address identify what? Different network segments. And the most common version of IP address that we are all familiar with is what? The IPv4, IP version 4, which uses the formats shown here. So an IP address in the version 4 will consist of what? 4 numbers being separated by a period or a full stop. And each of these numbers is between the range 0 and 255. So you realize with the number of devices that are connected to the internet today, chances are we will run out of IP addresses. And the question is, what will happen? In fact, let me put it this way. Already we have run out of what? IP version 4 addresses. And the question that I can pose to you is, what is going to happen? How is that going to be resolved? I will leave you to ponder on that one. Right. So to cater for the resultant loss or lack of IP addresses as a result of the running out of what? IP addresses in IPv4, came in the concept of IP version 6, which offers a maximum number of IP addresses for the current use and for future use. Whereas the IP version 4 addresses at a maximum of about 4.3 billion IP addresses. IP version 6 is unlimited, or it will never run out of what? IP addresses. So you can imagine with IPv4 we had 4.3 billion unique IP addresses. Now with the 4.3 billion IP addresses, the world is about 6 billion people. Now today's world, each individual is a mobile device that connects what? To the internet. And some individual will have more than what? One device connecting or requiring an IP address for it to connect to a network of some sort. Organizations will have quite a number of devices that can connect to the network, and this device will require what? IP addresses. So let's put it, for example, let's say I have my organization. It has probably 5 services that it offers, and each service has its own IP address. What this means, so not that each service has its own IP address, each service has its own website. And for this website to be accessed, it will need to have an IP address. So what it simply means that already the organization has taken 5 IP addresses from what? The 4.3 billion IP addresses that we have. We haven't gone to the hardware or to the physical locations where the organization has offices. Let's say in Zimbabwe, with 10 provinces, it has 10 offices, 10 provincial offices. And each of the offices has an IP address allocated to it by its ISP. So it means this organization, the 10 offices, has taken another 10 IP addresses plus the other 5 for its services. So you can see how quickly IP addresses were swallowed up in IPv4. So this is what motivated or what resulted in in us coming up with IPv6 addresses, which consist of 8 groups of 4 hexadecimal digits. I think if you've checked on your mobile devices, you might have come across these numbers, the IPv6 addresses. So they came in to address the issue that we're now facing because of Of running out of IP addresses. We want to look at the next issue, which is subnet mask.